Okay, so the good news is, I know some of you are looking at this and thinking, oh my gosh, what are we doing here? Well, the good news is we have already talked about a bunch of this, okay? So this is all going to sound familiar. The only new part is going to be the actual graph, okay? So here's what I mean. When I sketch problem number A, this is 2.6A, and I need everybody paying attention. When I sketch this, there are certain pieces of information that I have to put in, but I already know how to find them. I'm going to put in the vertical asymptotes. This is the stuff we're going to put in for every problem, okay? The vertical asymptotes, the horizontal asymptotes, and now that we're a little bit older and more mature, we're going to call those sometimes end behavior asymptotes. They're the same thing. So if I refer to it as an end behavior asymptote, I'm talking about the horizontal asymptote. We're going to find the X-Intercepts. We're going to find the Y-Intercept. And we're going to find any holes that we may have. Now, all of those things we have talked about before. Do you remember, we did it all way back in the very, very beginning of the year. Do you remember anything about any of that? Can you find any of those things for this equation right here?
X and Y intercepts.
Okay, and how do we find X and Y intercepts? All right, let's look at the Y-intercept for a moment. Where would the Y-intercept, and where do I put it? Do I plot it out here somewhere? Do I plot it up here somewhere? Where does the Y-intercept get plotted? On the Y-axis. So I don't know where it is yet, but somewhere on this axis, right? Yeah. Tell me about every single point on this axis. No matter where I put it, what's true about the ordered pair?
The X is 0.
The X is 0. So if you want to find a Y-intercept, you are going to let X be 0. Now, I shouldn't have to write that down for seniors in high school. It needs to make sense to you that if you want a Y-intercept, it's going to be plotted here, which means X is 0. So put 0 in for X, what do you get? Negative 2/3. So my Y-intercept is right here at 0, negative 2/3. Now, similarly, if I'm looking for X-intercepts, and this problem only has one, but it is possible to have more than one X-intercept, it's going to be here, right? And what can you tell me about every point on this line? Y is 0. So if I'm going to find the X-intercepts, I'm going to let Y equal 0. Now there's always some clown who says, if the problem is written like this, there's some clown that says, there's no Y in there. Yes, there is. This is the same as Y, right?
Yeah.
So I would solve the equation 0 equals X plus 2 over X minus 3. Now, how do I solve that? What would you do to solve that equation? You know how to do this. I mean, you've done this since like 3rd grade. How do you solve an equation like that? Multiply by X minus 3. Now, what is the really great thing that happens when you do that? What's this equal? 0. That just stays 0. So essentially, the denominator disappeared. And where's my X-intercept? Negative 2. So where did the X-intercept end up coming from? I let Y be 0, but ultimately, the X-intercept came from where? The numerator. All right. What do you remember about holes? I remember talking with you about holes. What do you remember about them? How do we get them? we could, there would not be anything wrong with that, but it wouldn't help me at all. And that really doesn't have anything to do with holes. There are some cases where we might want to do that. Megan, I don't think this is one of them. Jonathan?
Isn't it like when you factor and there's more than one of the same kind, or the same exact numbers?
So what happens?
So whichever one that you like cross one
You
out.
cancel.
Yeah.
Yeah. The only way you're going to get a hole is if you factor and cancel, right? You have to be able to factor and cancel. Anything to factor or cancel here? No. So this problem will have no holes. Many problems have no holes. The only way you're going to have one is if you can cancel. We can't, so forget that. All right, what about asymptotes? What do you remember about those? We spent time talking about those too. Tony?
I know you got it.
Don't you remember that conversation about comparing x's and x's like this? That gives me my horizontal asymptote, right? What's x over x? So my horizontal asymptote is the line where y equals 1. Would you agree with that?
Yeah.
How about vertical asymptote?
Whatever x can't be in the bottom.
It's right. It's what x can't be in the denominator. So your vertical asymptote is anything that makes denominator 0. We don't want a 0 in our denominator, right? We do not want a 0 in our denominator. So what would make our denominator 0? 3. So we're going to put a vertical asymptote there. And it doesn't matter how many times I say you have to label that x equals 3, y equals 1. There'll still be kids that just put 3 and 1 and I'll just keep taking off points. They're lines, x equals 3, y equals 1. Now, as soon as you have all of these on the graph, then you're ready to actually sketch it. Now this part we haven't done before. This is the new part. We're going to actually sketch our graph. Now, think of your BFFs. Think back. Did you have any BFFs that had asymptotes in them like this, that crossing asymptotes? Any BFFs that did that? Someone remember? No, the exponential actually has an asymptote, but it only has one. The exponential has an asymptote here and looks like this. What? The identity has no asymptotes. The identity is the one that goes like this. That's the identity. There are no asymptotes in that one. Jonathan?
This is the one, I don't know the name of it, but it has one right here and then it mirrors.
Yep. Anybody remember what that one's called? That's the one I'm referring to. There's an asymptote here and an asymptote here, and it looks like this. That's the reciprocal function.
That's what I meant.
So, what's the equation for the reciprocal function? Anybody remember?
1 over x.
Y equals 1 over x. So it's the only one, except for the logistic function, which is that weird wacky thing. It's the only regular BFF that has a fraction. This is a version of the reciprocal function. Now, it's not the exact same picture, obviously, but it's the same basic idea. So do you have here's your asymptotes crossing right here. These 2 points have to be connected. Do you have a sense that this is what this looks like? Based on the fact that these 2 points right here have to be connected, and this is a fraction like the reciprocal function. Does that make sense to you? Now, if you're putting the pieces together, then you ought to be able to draw the other part of the curve. What do you think the other part of the curve looks like? What's the right side look like? Are you guessing it looks like this? And if you guess that, you're right. Now, let's talk about that, because I have the benefit of zillions of years of experience and having done zillions of these problems. So that's easy for me. But you're brand new. So what can you be thinking about? Well, first of all, I've given you a hint that this is a version of the reciprocal function, and you know what the reciprocal function looks like. Secondly, if you tried to draw something else, maybe you would try to draw this. That would be impossible. It would be impossible because if you tried to draw this, see what happens right there? What would I call that? That would be called an X-Intercept. And didn't you already tell me that the only X-Intercept was right here? So you're not allowed to cross over here, so that can't be. Well, let's say it's still not making sense to you. Then what you're going to do is set up a T-chart. And you're going to say, Mrs. Ford, I don't know what's going on out here. So I'm going to let X be 4, and I'm going to plug it in, and I'm going to get 6. So I'm going to plot the point 4, 6. And maybe that will give you enough information. If it doesn't, then you'll plot another point, and you'll plot another one, and you'll keep plotting until you figure out that's what it looks like. But I'm telling you, it's a version of the reciprocal function. It's going to have that shape. Now, sometimes they're here. Not this one, because I have these points right here. Megan?
How did you know to start with 4 for the T-chart?
Because my asymptotes are 3, and I'm trying to figure out what's happening to the right. I wouldn't have had to pick 4, it just made the most sense to me. I need to pick something bigger than 3 though, because I want to be out this way. Does that make sense to you? Jonathan?
Do you care what the other one looks like where it is, where it's plotted? Or does it just
Well, not exactly, because we're just doing general sketches here. But I mean, I don't want to see something like this out here. I mean, that would be wrong. I want to see some kind of curve, but the exact position of it, no. All right, so now we're ready for the next one. Ready for B. And I'm going to go ahead and leave this up here because we need this information. Erase all this. And now we're going to do the next problem. Okay, so here we go. We're going to talk about, we're going to graph all that stuff. And our problem is x minus 2 over 1 minus x. So tell me what I have this time. What have I got?
Y equals 2.
What's y equals 2?
X-intercept.
My x-intercept, it would be x equals 2. My x-intercept is at 2. That's exactly right. The intercepts are points. I'll put that here. This is a point and this is a point. These are equations. They're lines. So they're equations. Okay. So my point 2 comma 0 for my x-intercept. And again, Geechee got that by saying 0 equals x minus 2 over 1 minus x. He multiplied both sides by the denominator and it disappeared. So he solved the numerator and got 2. Good. What else? Fit?
-2 to y.
The y-intercept is -2. 0, -2. Remember, it's a point, so I'm going to plot it there. And you're exactly right, Finn. And you got that by putting in 0 for x. So your top was -2 and your bottom was 0. That's -2. That's exactly right. All right, what else? No holes. This is another example, no holes. Remember, the only way you can get holes is if you can cancel. There's nothing here that cancels. Okay. Asymptotes. X equals 1 is your vertical asymptote. Kids, now look, if you put a 1 in for X, wouldn't that be 0? And it's not allowed to be 0, so you have a vertical asymptote at 1. Good. How about horizontal? What do you think? Look back at the last one. How do we find the horizontal in the last one?
X over X.
We did X over X, so let's do X over X here. What do I got? I have X, 1X over negative X. What is that? Negative 1, so I have a horizontal asymptote at Y equals negative 1. Now, this is the important stuff. We're about the important stuff. I'm done. I got it all up here. So based on what I have, can you envision a picture? Now, this is still a reciprocal function. It's still set up as x's over x's, just like the reciprocal function. Can you envision it? What's it look like? You got that point right there. So are you seeing something that looks like this? If you're not seeing that, then you're going to set up a T-chart and you're going to plot some points. But you don't need to do that if that makes sense to you. Now that's only half the picture. Where's the other half? Up here. Connecting that point. Remember, you plotted that point for a reason. You have to go through it. Don't touch your asymptotes. Does that make sense? I see it's going to be a different ball game. You can look at it and tell it's a harder problem. Everybody ready? Okay, now we're going to do problem C. I'm going to answer all these same questions for problem C. As I was writing it down, I was thinking about how I was going to start. What do you think went through my mind as I wrote down that problem? To factor it. So the top factors how? X plus 2, X minus 2. And the bottom factors how? X plus 3, X minus 3. Now I got a lot of factoring going on, but does anything cancel? No, which means once again, my picture simply has no holes. Because it's not about the factoring, it's about the canceling. All right, so what do I have? I don't have any holes. What do I have? What do I have going on here? Okay, I'm not going to tell you. I need somebody to come up with something. What? Is what? So I have a point on the x-axis to an x-intercept at 2, and I also have one at negative 2. Look, I have 2 x-intercepts this time. I have one at 2 and one at negative 2. Now one more time, I'm not going to do this anymore. This is the last time, so you need to pay attention and write it down if you need to. To find an x-intercept, I let y be 0. So I would have the equation 0 equals x plus 2, x minus 2. X plus 3, x minus 3. To solve that equation, I'm going to multiply the denominator over to here to get rid of the fraction. What's going to happen to it since I'm timesing it by 0? Gone. So all I have left is this. solve the numerator. To find your X-intercepts, solve the numerator. So I've got two of them because there's two parentheses up there, two of them. All right, what else do I have?
0, 0.
What's 0, 0?
Y-intercept, isn't
No, my Y-intercept wouldn't be 0, 0. If I put 0 in, what do I have on the top? If I put in 0?
it? 2 minus 2.
2, no, the times. It's times.
Oh, -4.
So it's 2 times -2, so it'd be -4. And what do I have on the bottom? -9? It's times. These factors are times each other. So my Y-intercept is at 4 9s. Do we have any asymptotes going on? I have 2 vertical, Caroline. You're exactly right. Where are they? 3 and -3. Caroline says there are 2 things that make our denominator 0. That means I have 2 vertical asymptotes. One at 3 and one at -3. Vertical asymptotes make the denominator 0. So that would be -3 and 3. 2 vertical asymptotes this time. All right, one more. I need a horizontal asymptote in there. Where is he? Well, it wouldn't be x over x, it would actually be x squared over x squared. But the result's the same. Y equals 1. This is your horizontal asymptote right here. Y equals 1. Oh, this is freaky. All right. In the middle, this graph is actually in 3 pieces. We got the left side, we got the middle, and we have the right side. And Ted says, in the middle, Mrs. Ford, it looks like I've got a parabola-ish thing. Now, I'm not going to call it a parabola, it's a parabola-ish thing. Right? Does that make sense to you, given the points that we have plotted already? Now we got to figure out what's going on out here to the sides. Anybody have a gut feeling? It's this. You're exactly right. If that's what you're thinking, you're exactly right. Now, a couple of things. First of all, again, I have this huge advantage because I do this for a living, okay? I get that. But there are a couple things I want you to think about. First of all, is this still a fraction? So it's still going to have some characteristics of the reciprocal function. Now, it is way different, but it has some of the same characteristics. Second, I know something happens out here. I know that as the curves go off the page, they get closer to their asymptotes. So you're never going to have a picture like this. That is not going to happen. When you have an asymptote here and an asymptote here, your only 2 choices are what I drew and this one. These are the only 2 choices. Because as it goes off the page, it's going to get closer to that line. And as it goes down off the page, it's going to get closer to this one. It's never going to be something out here, ever. How do I know it's the top one and not the bottom one? We already talked about it today. Listen, if you can't figure this out, you're going to have to plot points. And that takes a ton of time. Exactly, Jake. You can't have another X-intercept. You already told me it crosses here and here. That means it does not cross anywhere else. So whatever you draw can't be crossing the x-axis. All right, so it can't be that one, so it must be that one. And same thing on this side over here. But again, if that doesn't make sense to you, if that's not clicking yet because you haven't had enough experience, you're going to set up a T-chart And once again, Megan, since that asymptote's at 3, I'm gonna start with numbers like 4, 5, and 6. Over here, I would start with numbers like -4, -5, and -6. All right, we're gonna do one more. And then we'll call it a day. All right, so what's the next one? Oh, my land. Whew, this is a doozy. All right, how do you suppose I should start this problem? I need to factor it, I surely do. So let's get it factored. The top factors as how? How does the top factor? X minus 5 plus 1. I'm on problem D now. And if I take a 2 out of the bottom, I'd have x squared minus 4. So is my bottom 2 times x minus 2x plus 2?
Yeah.
We all good? Now we're completely factored. Once again, what didn't happen? No canceling, so this one's not going to have any holes. That's fine, there's none in it. What does it have though? It has some stuff. What does it have? Bingo! How do we get x-intercepts? We solve our numerator because the denominator disappears because you put a 0 over here. So he says I have x-intercepts at 5 and -1. Hopefully you're taking some kind of notes so you can remember this when we get it back out next week. All right, what else do I have? Good, x-intercept's done. Do you have a y-intercept?
Yeah.
And how do I find it? Put 0 in for x. So if I put 0 in, I get -5 times 1 over 2 times -2 times 2. I'm putting 0 in for all of the x's. And I get 5 over 8. So 0, 5, 8. Oh wait, maybe I'm a little higher. 0, 5, 8. That's my y-intercept. All right. Any other ideas about stuff I need to put in? I need to put all this in before I start sketching. Vertical asymptotes would be where? There's 2 of them. Where are they? 2 and -2. Kids, vertical asymptotes are what makes the denominator 0. If you put in a 2 or a -2, you're going to get 0 in the bottom. That means you have vertical asymptotes there. One more, I need a horizontal asymptote. Where do you think it is?
X squared over 2x.
Okay, so it's x squared over 2x squared. Jonathan's looking at the original problem, the foiled out problem. What does that mean? I'm going to have an asymptote where? 1/2, which is underneath 5/8. So here's y equals 1/2. Now, for the first time, something very, very funky is going to happen. And it's going to make you feel uneasy at first, but don't be afraid, it is fine. Take a look at these 2 dots right here, and they must be connected. Do you have any idea what the shape is going to be here in between these asymptotes? It is not a parabola this time. Do you have an idea what it might be? It's a squiggly. It is one of our are squiggles, like a cubing function. Now, what is making you a little uneasy? What did I do right there? I crossed the line. Now, I am allowed, you are allowed, we're all allowed to cross horizontal lines. You are never allowed, I'm not allowed, no one is allowed to cross a vertical line. You may cross horizontal asymptotes. It happens a lot. What I need for you to understand is those 2 points have got to be connected. Now somebody might say, oh, Mrs. Ford, I could connect them. What if I connected them with a parabola? What would be wrong with that? You would cross the x-axis again, and guess what? You're only allowed to cross here and here. Don't do anything that crosses an axis other than at a point that you plotted. That's why I make you do that first. So it's got to look like that. Perfect. Any ideas what it looks like out here? Looks like a reciprocal function out here. It sure does. Just like that. Why? It can't do anything else. And that makes sense to me, and if it doesn't make sense to you, I'll try to explain it one more time. It's going to approach its asymptotes as it heads off the page. The only 2 possible things are this curve and that curve. That's it. Those are the only possibilities. It's not that one because that one doesn't contain that point. If you don't get it, then you're going to set up a T-chart and plot points. Who are you talking to that's more important than me? No one. Right now, no one. Even Mom, God bless her. No one is more important right now than me. That's what it looks like. Any ideas what it looks like over here? Oh no, there's something over here. You're going to have a left side in this picture. And your choices are this and this. It's the top one. Why is it the top one? Because it can't cross the x-axis, so it's got to be on top. You are just beginning. You say, Mrs. Ford, I don't get that. Plot points. Set up a T-chart. Plot points. Okay.